Good morning. Good morning, ladies and gentlemen. How y'all doing? My name is Jon Belkowitz. I'm the CTO, the Chief Technical Officer at Intelligent Concrete, where we focus on the magical world of concrete, bringing consensus-based education to a larger concrete and construction industry. I have the privilege, nay, the pleasure to give you what we call a little peek into that magical world of concrete, focusing on a new technology that has the capacity to rejuvenate dead and dying concrete, ultimately hydrogels for rejuvenating deteriorated concrete. Now, before we get into the meat of the presentation, I want to recognize the why behind all of this. Why should we care? Why should we worry about this? Why should we do anything? Why should we be taking notes? And why should we challenge Jon? And yes, I'm talking about myself in the third person at the end of this presentation. And the biggest problem here is that our concrete infrastructure is falling apart at a dramatic rate. If we had to replace all of the deteriorated concrete for bridges and water reclamation projects that were deficient tomorrow, we'd have a price tag of $42 trillion, a landfill that would be astronomical, and a resource budget that we just couldn't meet. The American Society of Civil Engineers has given us, our national infrastructure, a grade of a C minus. And just to put that into perspective for you, if our concrete infrastructure was trying to graduate college, it wouldn't have a high enough GPA to get a diploma. That harsh reality that I keep talking about is failure is not an option in our industry. When concrete fails, things get ruined, people die, it's a bad situation. Now, I'm not trying to say that the concrete industry is broken, but let me just give you one more fact here. Setting the stage, there are over 600,000 concrete bridges in our national inventory. This establishes a yearly budget of $48 billion into the concrete industry. Now, an additional $8.3 billion is put back into concrete every year to deal with the maintenance associated with physical and chemical attack. Now, let's say I bought a truck for $50,000. And the first year I had that truck, and each year after that, I had to put in an additional $8,000 to deal with the maintenance associated with physical and chemical attack. Now, more than likely you would have a Ford, but taking it down to that level, we can all see that there is a problem that needs to be fixed. The good news is that there is a solution to our concrete infrastructure problem. Take a deep breath. We know that the root cause of decay in concrete is concrete's molecular structure. This picture here, I choose the pictures on here for very specific reasons. I want you to be interested in this, and I want you to see the science as not only something that is one of our biggest obstacles, especially with things that we can't control like the ambient environment, but it's something that we can take advantage of. What we know is that essentially concrete is a hardened sponge. Water, salt seeps in, evaporates out. Some of the salts stay behind, some of the water stays behind. You have volume change that leads to cracking. And deteriorated concrete from cracking is at the root of America's infrastructure problem, our challenges. And all of that is that the concrete molecular structure. Now, over time, this this water migration and the salt deposition that I was talking about, those contaminants cause the slow breakdown and deterioration of concrete. Whether you're in Denver, over here on the left with alkali silica reactivity, just breaking down the concrete from within, or if you're here on the right in Tampa and you're dealing with brackish water, chlorides and sulfates that are causing, anything from calcium oxychloride formation to sulfate attack, and just saying reducing that cover of concrete over the steel and ultimately breaking down that reinforcement of concrete. So we go from this tension failure, which gives us running room when the concrete starts failing, through this transition zone into this compression zone, which creates that environment for the ultimate concrete failure. And I wanted to illustrate this problem, how water and salts contaminate the breakdown of concrete over time. And the first thing that we have is this drying out of concrete. Concrete is a hardened sponge. Our concrete dries out and then fills up with water. And it goes through this process, this vicious cycle. And what that vicious cycle does, and I said it earlier, it causes a volume change. And concrete doesn't like that volume change. On a scientific scale, you would say these atomic dislocations, they're not elastic, they're more plastic, and they tend to snap and pop, break and crack, creating more of that porous nature. And that water, those salts, ultimately lead to that reinforcing steel, which causes that corrosion and bleeding and the contaminants and that vicious cycle I mentioned at the beginning of this slide. We talked about a solution, and it's taken me 9 slides to finally get to that solution, but I wanted to paint that picture, not just the rudimentary illustration, but the water plus contaminants, because that's what hydrogels take advantage of. When we have a hydrogel, we're not putting it into brand new concrete. We're using it on as a topical additive for deteriorated and damaged and cracked concrete. The hydrogel technology is sprayed liberally onto the exterior of the concrete surface, and it seeps into concrete pores. Now, most hydrogels require a saturated surface dry condition for the concrete so that you have that known combination of water and those contaminants. And those contaminants, chlorides, alkali, sulfates, iron oxides, carbonic acid, could be a whole slew of things. The hydrogel solution interacts with these contaminants and interacts with them in a way that starts developing that hydrogel technology that was originally in a liquid solution into a stacked 3-dimensional microstructure that has strength-bearing components to it, the very same strength-bearing components, assuming you have the right technology, that we find in our parent binding matrix, the calcium silicate hydrate. And over time, these hydrogels transform into more of that superhero, that backbone of concrete strength to heal those concrete pores. Got a little animation here. So when we're using the technology, we have a concrete pore, saturated surface dry condition. We spray on the solution. It seeps into the pores, and this is where the polymerization process goes. Our immature gel leads up to a mature gel that ultimately makes a stronger and more durable concrete. When we get a chance to look at the hydrogel in a laboratory setting, this is the hydrogel. I mean, this is a few minutes after it's been combined with the simulated cement pore solution, and it has gone from a sprayable liquid to this hardened gel. And the hardened gel can hold its own shape. It can bond to the deteriorated and cracked and um, corroded uh, materials in the composite structure of our concrete material, and ultimately lead to our biggest problem in the concrete industry. We see this solution from the side of the engineers and the architects that hey, we're going to design a bridge that is going to last 50 years. And what that ultimately does to us is it forces a promise that we're going to keep a bridge or a concrete structure in place for this X amount of time. And if we don't keep it in place, then we fail at meeting that objective. So we find that our engineers in the different DOTs, as well as those municipalities, those marine entities, have to hobble the structure along. And we'll get into one of those case studies here in a second. In lieu of tearing it out, here's a great example. The hydrogels have been found to extend the life of a bridge or a concrete infrastructure by 15 to 25 years, even if they're at the end of their design life, by taking advantage of that cracked and deteriorated environment. The increase in usable life of concrete pavements and infrastructure has also been seen to been increased by 30 and 50%. And one of the projects that we're running in Fort Wayne, Indiana, is a concrete tunnel under a concrete highway. It was built 2002 and was going to be demolished, but with the help of the hydrogel technology that we've used here, and specifically this is a combination of products from Eddystone, we found that we could effectively manipulate the molecular kinetics of this cracked and deteriorated concrete to slow the mechanics that cause this deterioration. You can see from this picture that we've got concrete on the floor. From the ceiling, you can see this cracked and deteriorated concrete. Let me get into the case study. It was a cruise tunnel. The concrete tunnel was set for demolition. Our job was to measure the impact and capacity of this Eddystone hydrogel technology to rejuvenate cracked concrete. Now, significance of this phenomenon was elucidated by the employment and deployment of a modified version of a concrete wicking test. And we went out to the job site. We were able to show that the technology is extremely easy to use and fast. The prep and application includes power washing the concrete to remove excess salt and weaken concrete. You allow the concrete to get to this saturated surface dry condition, this SSD condition, and then in multiple passes of 500 to 750 square feet per gallon, you're applying the hydrogel or Eddystone technology to an ultimate dosage of 125 square feet per gallon. And what we did for this cruise tunnel project, we had 7 full construction joints over a total length of 400 feet. The construction joints were spaced 40 feet apart, and they were 14 feet tall by 16 feet wide. To evaluate how the Eddystone impacted the concrete, we had a reference side. So every joint, we had a side where both sides were clean, but we had a side that we applied the Eddystone, which you see is the left-hand side here, where it was cleaned and the Eddystone was applied, and the right-hand side where it was only cleaned. Later on, 4 months after our application process, we came back, took some cores, took some pictures, and we measured the wicking or the concrete sorptivity using ASTM-C 1585. So we had a number of joints where we used different types of the Eddystone technology, but the ultimate combination based on the deterioration was a use of 2 different types of hydrogels that not only densify the permeable deteriorated matrix of our concrete composite, but also use the impurities to create that healing matrix that can be comparable in strength and durability to the parent material. Here was the dosage of those two different materials. We went through the cleaning process and applied the Duragel first at 250 square feet per gallon in 4 passes. And then we did the same thing with Density Gel with a 10 to 15 minute break in between passes. Came back 4 months later, took pictures, and you can definitely see the change in these pictures in the upper right between the Eddystone joint on the left and the reference joint on the right. And when we took those measurements using ASTMC 1585, albeit a modified method, we saw up to a 30% reduction, 40% reduction through our primary and secondary absorption. And going back to some of the other joints, it was consistent throughout the 7 different sections where we're seeing this reduction in migration of water through the concrete. And ultimately, we're not seeing that the Eddystone is a concrete sealer. It's just the opposite. The hydrogel technology, the Eddystone, works with the water to create more of that backbone of concrete strength. So effectively what that means is if you still wanted to put the Band-Aid on there, on your deteriorated concrete, especially if you've had a lot of mass loss or concrete cover loss, you could do that after applying the Eddystone. Figure the Eddystone is the antibiotic to your Band-Aid. And, the wrapping up this case study, this is what we came back to 18 hours later. There was a significant amount of rain. These joints had no flashing over them, so water was just seeping through. But the next day, you can see the difference where the Eddystone, the hydrogel technology, had an impact of reducing that water flow through the concrete joint and through the concrete, while the reference concrete, you can see where the Eddystone is applied. It's like bacitracin or Neosporin. It has that shininess to the surface after it's first applied. And then looking underneath the joint, you see that reduction in water flow. So the question is now what? We've sat through this 15, 16-minute presentation. You've got this information. Now is the time to act. This is a very easy technology to apply, to get out to the job site and then apply, and then easy to test later on. And getting to work with hydrogels, there are plenty of folks out there that can help you out, from universities to the competition. The folks that we work with do a wonderful job of informing the end users of what the technology is, how to use it, which is very palatable to the industry, especially the job or the time we have on certain job sites, and are excited to get in touch with you. And like I said, there's just too much damaged concrete to go around. Let's take advantage of this technology. Put us to the test. Put the technology to the test. And if it doesn't work, you know my rule. If you prove me wrong, that's a steak dinner for my vegetarians and vegans out there. That's a portobello mushroom dinner. To summarize this technology, to recap this presentation, I wanted to define a hydrogel, why we care about hydrogel, why you're sitting here and investing your time into this presentation. Furthermore, I wanted to go into how we use hydrogels, giving you a short review on corrosion, which I would love to spend more time in, but I wanted to go more so into how do the hydrogels impact the deteriorated concrete, and I did that more so with reviewing a case study that we're working on in Indiana. Now, what I'm hoping is that this is a call to action. And, one of the people that I look up to in the industry, Larry Sutter, once told me, John, there's only 2 ways of getting people involved in the concrete industry: beer and pizza, or getting them pissed off. So if anything, I hope I pissed off a few people in the audience and going to get you involved. we'll get back to my email address and my phone number so you can reach out to me day or night. I ask that you leave Sunday for Family Day, but don't hesitate to give us a call, shoot us an email. I would love to thank our sponsors, the Utah Ready Mix Concrete Association, the Intermountain chapter of the American Concrete Institute, always doing a great job educating the concrete construction industry with great knowledge and education for a wonderful skill set. And of course, I'd like to thank Eddystone LLC. The folks over there were just absolutely easy to work with, great to work with, and facilitated a lot of the funding for the research that was conducted and the presentation that was put together. So as I promised, there's my phone number. Give me a call. If I'm not available, leave me a message. You can even text me. That's a lot faster. Get back to the front of that presentation for my email address. Thanks for joining us. Go concrete. Beat asphalt. Beat asphalt.